As fisheries collapse, aquaculture becomes an increasingly important source of food for people worldwide. In Canada, aquaculture is commonly done by growing fish in cages that sit on top of the water, housing thousands of fish in a concentrated area. This intensive production results in uneaten feed and feces settling on the sea floor, forming a thick layer of what's referred to as flocculent matter. This layer smothers life on the sea floor, and it impacts ecosystems for months or even years. Current methods of environmental monitoring include collecting sediment and underwater video. While these methods are valuable, they're limited in scale and they take a long time to do, and it's important that we develop new techniques that can keep pace with the industry's expansion. Single beam echo sounders are a potential alternative because they can survey larger areas faster than collecting sediment or underwater video. An echo sounder works by emitting a ping and listening for its return. The time it takes for the signal to return and the strength of this signal are both characteristics that we can use to identify objects in the water. So the question I had was, could we use data from an echo sounder to detect and discriminate flocculent matter from other substrates like boulders or sand? Could we use sound to detect pollution on the sea floor? To answer this question, we turn to machine learning, which put simply is a field that combines computer science and statistics, giving machines the ability to learn from previous experience. But before we could create a model, we first needed to provide examples for it to learn from. And to do this, we overlaid echo sounder data with nearby images of the sea floor. The best model can tell the difference between flocculent matter and other substrates with 96% accuracy. When presented with novel information for an entire bay, a figure like this can be generated, showing predictions of where this footprint of aquaculture production is located. So I've essentially spent the better part of a year building a really accurate feces detector. So the question naturally becomes, what's the use? Well, a recent study looked at different ways of returning the seafloor to pre-aquaculture conditions, and they concluded, perhaps unsurprisingly, that the best way of doing this was by picking up the messes we leave on the sea floor. With my method, we can now find it, we know where to look, and I think with my method we can help our oceans recover a little bit faster. Thank you.